Welcome back to the channel, where we explore ideas shaping tomorrow's technology. Today we dive into space-based data centers, powerful servers operating in orbit to process data faster, greener, and closer to satellites in the coming decade ahead across Earth. From reduced latency to energy efficiency and security, this concept could redefine cloud computing on Earth. Stay with us as we explain how it works, why companies care, and what comes next for global infrastructure. And don't forget to subscribe. Number 5. Orbital servers. Orbital servers refer to data centers placed in space, typically in low Earth orbit, designed to handle data storage and processing beyond the planet's surface. These servers operate inside specially engineered satellites or modular platforms that protect hardware from radiation, temperature extremes, and microgravity. The concept builds on existing satellite technology, but expands it to include large-scale computing tasks rather than simple communication or observation. By operating in orbit, these servers can directly interact with other space-based systems, such as Earth-observing satellites, space telescopes, and global communication networks. Data generated in space can be processed immediately without relying on constant transmission to ground stations, reducing latency and bandwidth congestion. Orbital servers also represent a shift in how infrastructure is distributed, moving critical digital assets away from centralized locations on Earth. This approach has implications for resilience, as space-based systems are less affected by terrestrial disasters like earthquakes, floods, or power grid failures. Overall, orbital servers form the foundational layer of space-based data centers, enabling computation to take place where data is increasingly being created, while redefining the boundaries of traditional cloud infrastructure. Number 4. Cooling advantage. One of the most discussed benefits of space-based data centers is the natural cooling environment available in orbit. On Earth, cooling systems consume a significant portion of a data center's total energy usage, often requiring complex air conditioning, liquid cooling, and heat management solutions. In space, the surrounding vacuum and low temperatures offer a fundamentally different thermal environment. Heat generated by servers can be dissipated through radiative cooling, where thermal energy is released directly into space, without relying on air or water. This can greatly reduce the need for heavy, energy-hungry cooling equipment. Designing systems to manage heat in microgravity still presents engineering challenges, but the absence of atmospheric constraints opens new possibilities for efficient thermal control. Reduced cooling requirements can lead to lighter infrastructure, lower energy consumption, and longer hardware lifespans. Efficient cooling also supports higher density computing, allowing more processing power to be packed into smaller orbital platforms. Over time, this advantage could make space-based data centers more energy efficient than their terrestrial counterparts, especially as global demand for computing continues to grow. Number 3. Faster space data. Space-based data centers enable faster handling of information generated in orbit by eliminating the need to transmit all raw data back to Earth. Satellites used for imaging, navigation, climate monitoring, and scientific research produce enormous volumes of data every day. Currently, much of this data must be sent to ground stations for processing, which can introduce delays and bottlenecks due to limited transmission windows and bandwidth constraints. With servers operating in orbit, data can be processed, filtered, and analyzed immediately after collection. Only the most relevant or refined results need to be transmitted to Earth, significantly improving efficiency. This approach reduces latency, which is especially important for time-sensitive applications such as disaster monitoring, space situational awareness, and real-time communications. Faster in-orbit data processing also supports advanced technologies like artificial intelligence and machine learning, which can be deployed directly on orbital platforms to detect patterns or anomalies. By shifting computation closer to the source of data, space-based data centers create a more responsive and scalable space data ecosystem, supporting both commercial and scientific missions. Number 2. Energy from sun. Energy supply is a critical factor for any data center, and space-based systems benefit from direct and consistent access to solar power. In orbit, solar panels can receive sunlight for extended periods without atmospheric interference, allowing for highly efficient energy generation. Unlike Earth-based renewable sources, which are affected by weather, seasons, and day-night cycles, solar energy in space is more predictable and stable. This reliability makes it well-suited for powering continuous computing operations. Space-based data centers can integrate large solar arrays and advanced energy storage systems to maintain operations during orbital eclipses. Using solar energy reduces dependence on fossil fuels and lowers the environmental footprint associated with data processing. It also aligns with long-term sustainability goals as global energy demands increase. Efficient energy generation in space can support high-performance computing workloads while minimizing operational constraints. Over time, advancements in solar technology and power management could further enhance the viability of space-based data centers as a clean and scalable energy-driven computing solution. Number 1. Earth impact. The deployment of data centers in space has the potential to significantly reduce the environmental and infrastructural strain on Earth. Traditional data centers require vast amounts of land, electricity, and water, contributing to heat pollution and increased pressure on local power grids. By moving part of this digital infrastructure into orbit, land use can be reduced and urban areas can be relieved from hosting energy-intensive facilities. Space-based data centers also help lower waste heat released into Earth's atmosphere, addressing concerns related to climate and thermal pollution. Additionally, distributing computing resources beyond the planet enhances overall system resilience and redundancy. Earth-based data centers remain essential, but offloading specific workloads to space can balance demand more effectively. This shift represents a new model of global infrastructure, where Earth and space work together to support growing digital needs. The broader impact includes environmental benefits, improved efficiency, and a reimagining of how humanity manages data in an increasingly connected world. Thanks for watching and exploring this futuristic idea with us today. Space-based data centers could transform how the digital world operates beyond Earth. If you found this video useful, share your thoughts in the comments and stay connected for more future tech stories right here weekly. And remember to subscribe.